Gia Professor Chen Gisun, and he would be happy to say something about paradigm shift in NLP research, some case studies, and I hope you will learn more from him. Thank you.
Thank you. Hi, good morning. It's my great honor to give this talk. First, welcome to China, welcome to HIT. My name is Chen Jiesun. Currently, I'm an associate professor in Research Center for Language Technology, Faculty of Computing, HIT. So today, the topic of my talk is paradigm shift in natural language processing research. Case study on fake news detection and name identity recognition. Okay. Yes. So this continents three parts. First is paradigm shift in natural language processing research. How you have background for natural language processing? How many of you heard? Okay, many of them. Thank you. So I just give a quick definition for natural language processing. It's a field of computer science and linguistic concern with interaction between computers and human beings. NLP is, it's not a big research field first. Okay, but with the development of large language model, NLP is becoming hot because everyone knows language model currently because it's widely used all over the world. Okay, especially from the occurrence of ChatGPT. Okay, my child is 9-year-old. Okay, it's primary school at grade 3. He uses the large language model almost every day, okay, to finish his homework, to answer all his, kinds of weird questions proposed by himself. So NLP is important in large language model, okay. So it's begun as a branch of artificial intelligence. So NLP is focused on cognitive computing, okay. We just learn something about computer vision. It's kind of different computing compared to cognitive computing. Okay, so modern natural language processing algorithms are grounded in machine learning. Okay, especially statistical machine learning. Actually, deep learning and large language model there are all kinds of statistical machine learning. Okay. So why I say we have a paradigm shift in NLP research? Okay, the research is kind of old-fashioned. Okay, different time have different main technology. Okay, so at the very beginning, NLP research use some experience method or expert method. We just use some rule to finish some NLP task, like a machine translation. Okay, so when we translate Russian to English or English to Russian in 1950s, most systems use rule-based methods. Okay, just like a dictionary lookup. Okay. Because at that time, we do not have a powerful computer resource and do not have lots of electronic language data. Okay. Also, we do not have statistical machine learning method. Okay. But from 1990s, we have some, statistical machine learning method occur. Okay, at the time it's quite look at nowadays. Okay, we say large language model is occurs because we have lots of data and lots of computational resource and new algorithm. Okay, currently the new algorithm is deep learning, but at 1990s the new algorithm is machine learning. Okay, currently we call it shallow machine learning compared to deep machine learning. Okay, at that time the denominator, the denominator or the most popular machine learning method is support vector machine. Okay, SVM is also proposed by a Russian scientist. It's okay. So from 2010, okay, we moved to a deep learning area. Okay, at that time, all kinds of NLP tasks are solved by deep learning method. Okay, actually, not only natural language processing, but also other fields like speech recognition and image processing. Actually, deep learning method is more successful in computer vision and speech processing. In NLP domain, deep learning is not so successful like other domain. Okay, things changed from 2018. Okay, from 2018. At the time, a model called BERT, B-E-R-T, occurs. Okay, it's a kind of pre-trained model. Okay, kind of pre-trained model which can dramatically improve the performance of all kinds of tasks in natural language processing. Okay, and previously, different tasks like machine translation, summarization, use different models, and different language use different model. Okay, so for each task in each language, we have a specific model. Okay, but with after the occurrence of pre-trained model, things changed. We can use one model to handle all tasks in all languages. Okay, that's a big shift in research paradigm. Okay, so BERT. Okay, after that, the model become larger and large. We have large language model like ChatGPT. Okay, still, we know to build a large language model, the first step is to pre-train it, right? It's the technology actually from pre-trained language model. Okay, so in pre-trained language model, we have like BERT. Okay, this is a backbone model. Okay, for different tasks, we can just use the training data from different tasks to fine-tune it. We do not need to change the backbone model. Okay, and then we can use it to solve different kinds of tasks. Okay, with the large language model, we even do not need to fine-tune it. We can just directly use it. Okay, just use natural language to communicate with the model and let them finish the task for users. Okay. Okay, now let's take a fake news detection, okay, as an example to see how to use a large language model to solve fake news detection. Okay, you may wonder, you just mentioned with large language model, you do not need to fine-tuning the model. Okay, the model can help you to finish your task. Okay. It can, but its performance is not satisfied. So we still need to find some way to improve its performance at specific task. Otherwise, we will lose our jobs. Okay. So let's see the background and objective of fake news detection. I guess we all know what is fake news, right? There's some misinformation or unreal news from the internet or some social network. So fake news can, bring a bad effect to our society. It can cause chaotic panic buying, can damaging people or organization images, can take human lives, okay, can even take human lives. Let's see some examples, okay? So in some country, if a rumor about biology laboratory will spread some new type of virus, okay, it will cause some fears to ordinary people. Okay, we often see some rumors like this. Okay, not in our own country, but in other countries. Okay. Also, it will cause chaos. Like the Tyler papers effect. Okay, when something, some people say something bad will happen, people will store some food or other necessary things. Okay, it will cause chaos. Okay, yeah, fake news can also cause death. Okay, like BBC reports, even authorities informed that hundreds have died from alcohol poisoning after viral rumors about its security effects. It's happened in 2020. We know at that time the world is still in pandemic. Okay. Okay. In this research, we focus on application of large language model in the field of fake news detection. Okay. Before large language model, fake news detection can be considered as a classification task. We can use different machine learning method, classification machine learning method like naive support vector machine, random forest to solve this task. We use some features proposed by some experts, including linguistic features. Usually, fake news may have different word, different writing style compared to real news. Okay, we can use a feature like this. We can also use some deep learning method to solve it. Okay, with deep learning method, we do not give the feature by ourselves. We let the model learn the features from the raw data directly. Okay, that's the advantage of deep learning method compared to shallow machine learning method. Okay. Okay. In this research, we have three research questions. First one is, can large language model be effectively applied to the task of fake news detection? Why this is a problem? Because we know large language model itself has hallucination problem. Okay, it will generate something unreal itself, so it can be used to recognize or detect fake news. Okay. And the second research question is how to enhance fake news detection use a combination of large model and language model and small language model. Okay, and the third one is, can large language model be utilized to address the challenge of fake news detection in low resource settings? Okay, low resource is often proposed research question in natural language processing domain. Although we have large language model, our technology is very advanced, but still there's some language. For some language, its electronic corpus is very scarce. Okay, for some language, they even don't have their writing character. Okay, only have speech. Okay, people know how to say it, but have no ways to write it. Okay, so how to deal with such kind of language. So this kind of situation is called low resource. Okay. Let's say the first research question: how to use can large language model be used to solve fake news detection? Okay. We have proposed a method enhance fake news detection with large language models through multi-agent debates. Okay. We have many ways to use the large language model. One way is prompt. We use prompt to communicate with large language model. Okay. Other way we can use like RAG, retrieval argument generation. Okay. And the third one is agent. Okay. Agent is a very popular word in the research, not only in research but also in industry. Okay. So in this research, we try to use agent, okay, as a way to use large language model. Okay. So how to define agent is actually very easy. Okay, we just give some description. Okay, we can. The description is about the role or the function of the agent. Okay, so we can use single large language model approach, which means we just write a prompt for large language model. The prompt is like, here is the news, please detect whether it's fake or real. Okay, this is a single large language model approach. Okay, we try different large language model and to see their performance. Okay, of course, we hope the large language model can output the reason for its judgment. So we use COT prompt, chain of thought. It sounds very complex, but actually it's only at one sentence. Okay, please solve it step by step. Okay, this one sentence can let the large language model to, or can let large language model to output its reasoning process. Okay. So this is a single LLM approach. Okay. How about we know when people may make mistakes often. Okay. But if a decision is made by several people or a group of people, the chance to make a mistake will decrease, right? So following this intuition, we propose a multi-agent debate, which means we use different large language model. Okay, we let them debate, and we got the final decision based on their discussion process. Okay. So when you have debates, okay, we hope people with different background, okay, without our different technology, okay, without people come from different background and with different skills, the discussion between them will have a more correct decision, right? So we can use diverse personal agent, okay? So the persona will include a fact checker, a journalist, and a data scientist. Okay, that's our 3 different methods. Okay, for the data set, we use two data set, politic fact and gossip corp data set. This data set actually quite large. Okay, we just randomly choose a part of the whole data set because use large language model is very expensive. We do not have enough money, okay, to do do experiments over large data set. Okay, that's a multi-agent debate framework algorithm. So how to let the agent debate? This is a process. It's actually quite simple. Okay, we just give prompt for different LLM. Okay, A1 to AK refer to different LLM, and our different agents. Okay, we can consider one agent refer to one LLM, and then we get the feedback or the output of different agents, and finally we can vote over all the decision. Okay. Okay. That's this algorithm. Our agents have same personnel, or we can consider them. We can consider all these agents have same prompt. Okay, but as we say, agent with different scale or different background may get better results. Okay, so we can set agent to different personnel. Okay, so the first one is fact checker. So how to indicate the difference between agent is from the prompt. Okay, so in this agent, it's a fact checker. We will say you are a fact checker. Okay, you will use your ability to detect whether the given news is fake or not. And the second one is journalist. Okay, so a journalist is supposed to have some investigative ability. Okay, to get some proofs for the decision process. Okay, and the third one is a data scientist. Okay, we hope it can use some skills of data scientists to check whether the news is fake or not. Okay. And with different personnel, okay, they will give different results. Okay, then we can have a debate process. Okay, and the debate process can include different rounds. Okay, and finally we can still use majority voting to get the final decision. Okay. So the process is not complex. Okay, very like human behavior. Okay. So that's an example of response generated by a single LLM using zero-shot prompting. Okay. So yeah, I guess you all have the slides, right? So it's too small. Okay. So the prompt is like this. You are a fact checker specializing in identifying fake news. For each piece of text you receive, determine its authorities and provide a clear verdict. Strictly answer using the following format. Prediction label, real or not. Reasoning, let us think step by step. Okay. The last sentence, reasoning, let's think step by step. Okay, it's a trigger to let large language model using chain of thought pattern. Okay, so we also need to let the output following format: prediction, comma, fake or real or fake. Okay, so as we know, we need to vote according to the output of different agents. So we hope the output format can be controlled. Okay, we can give some instruction and let the LLM to follow the instruction to get a unified output format. Okay, this is the output of different agent or large language model, like this is Llama, and this is Chat GPT 3.5. Okay, we can see the first output is prediction label, it's fake or real, and the following reason, and after reason is the reasons, okay, give output by the agent. Okay, here are some results on polyfactor data set. This column are different models. Okay, it's Llama 3, 8 billion. Okay, GPT 3.5 Turbo, and Wakuna 13 billion. Okay, and okay, each row is results given by a single large language model. Okay, and the last row is debate results. Okay, we use different agent to let them have discussion. Okay, and with diverse persona. Okay, we can see the last row gets the best performance. Okay, so the evaluation criteria including accuracy and F1. Okay. So we also compare debate with uniform prompt and debate with diverse persona. We can say diverse persona can give better performance compared to uniform prompt. Okay. Okay, that's results on gossip curve data set. We have same observation as the previous data set. And we also do experiment to try different discussion round. Okay, the effect of different discussion round. We found round 3 will get better performance because the reason may be because with more round, okay, we will input long context to large language model, okay, which will which may import more noise, okay. Okay, that's impact of different debate round. So usually we choose round 3, okay. That's the effect of different LLM. So previously we use different LLM, large language models when we have different persona settings. We can also use one LLM with different persona setting. Okay, still we can get better performance. Okay, with different persona setting. Okay. Okay, we just use one large language model and give him different prompts. Okay, and in this way we can still get a better performance. Okay, that's this picture shows a discussion process for different persona setting. Okay, so usually a news will contain not only text but also images. So it's a natural multimodal problem. So we we are trying to use some technology to improve the fake news detection. Okay, consider multimodal. So we propose IEM FND called regional enhanced multimodal fake news detection. Okay. We made up two main sections. First is conflicting regional generation using multimodal LLMs, and then we fine-tuning a smaller language model with generate regional as context. So how to generate a conflict region? So give a news, we do not know whether it's real or fake. Okay, we can let use a multimodal large language model, Lava next. Okay, we can say suppose this news is real. Okay, please give some reasons, and suppose this news is fake, and please give some reasons. Okay, and after that, okay, we can use a large language model to judge which is which suppose is right. Okay, previously we only have news itself, right? Now we use large language model to get more background or common word information for this news. So with more information, we hope can get a better result. So how to use the regional results? We can use fixed regional concatenation, or we can use regional order based on large language model judge. Okay, so if we do not know or we have no information about which suppose is or which hypothesis is right, we just concat them. Okay, if we know which is right, how we know we can use a large language model to judge which hypothesis is right. Okay, then we can put the right hypothesis before the wrong hypothesis. Okay. Okay. Anyway, we can get this part is text information, and we can use a pre-trained model called DBERT to encode this text information. Okay, how to use image information? We can use a pre-trained image model like a VIT, okay, vision transformer, okay, to get the image encoder results. Okay, we cannot directly combine text and image together, but if we can project them into a common semantic space, then we can easily use them together. Okay. So here, this picture shows the whole solution. Okay. First, we use Llama next. Okay, it's a multimodal large language model to generate some reasons for the given hypothesis. Okay, and then we concat all the hypothesis output and input the text information into a DBERT model. Okay, to get the text encoding results, and for the image part, we input it into a VIT model. Okay, it's a image pre-trained model. Okay, and get the gets encoding results. Okay, this part is text encoding result, and this is image encoding results. And we use attention, cross attention modular, okay, to combine them together. And then we got the final semantic encoding results. And then we can use this encoding results to do classification, whether the news is fake or not. Okay, this is experiment results. Okay, so because we are dealing with multimodal news, so we choose data set that contain multimodal information. Twitter and MR2. This is experiment results. So the first, these two rows, the results come from this paper. Okay, it's teaching large language model to interpret multimodal misinformation while knowledge distillation. And this row is our results. We can see our method is better than the comparison method. Okay, this is a comparison result with different baseline. Okay, on the over the same data set. Okay, we can see our method called REMFND still gets best results. Okay, this result is on Twitter dataset, and this result is on MR2 dataset. Okay, this is just a same information as the previous table. Okay. We also do some application study because this model has this method has many modular. Okay. Okay, we remove different modular. Decrease the results, so we can see each modular is useful for the final results. Okay. Okay. This part is for fake news for low resource situation. We choose a language called Swahili. And Swahili is widely spoken in Eastern African, including Kenya, Tanzania, Uganda, and DRC. Okay, so it's actually used widely in Eastern African, but it's limited. Its electronic resource is not is scarce. Okay, so we hope to find a solution to improve the fake news detection for news written in Swahili. Actually, it's quite hard for you to find the news purely written in Swahili. Usually, it's combined. The text is a combination of Swahili and English. Okay. Yeah, why we do research on Swahili? Because this is a foreign student called Nancy. She comes from Kenya, so it's one of his mother language. Okay, so first is how the first question is how to collect enough training data. Okay, so we propose some solution like use machine translation. We annotate by ourselves. We collect some raw data from Twitter, and then we annotate by ourselves. We also translate some news from English to Swahili. So in this way, we build a data set, a fake news detection data set for Swahili. This is some statistical information for the data set we build. Okay, for fake news, this is a word cloud, and this is a word cloud for real news. Okay, and with this data set proposed ourselves, we give some baseline experimental results. So we use MBERT, XM robot, African BERT. All these are pre-trained models. Okay, they are all the variant of BERT model. Okay, we also use a solution with the large language model. This time we do not use agent. We use fine tuning. Okay, as we know, to fine-tune a large language model for all the parameters is very expensive. So there are some some fine-tuning method which can only fine-tuning part of the whole model. So LoRa is a popular fine-tuning solution. So we use LoRa fine-tuning a large language model called Incuba LLM. Why we choose this? Because this large language model is not quite large, only have 0.4 billion, but it can support African language better. So this is some statistical information about our data set. Okay, and actually, after we finish this data set, we found someone also published a similar data set. Okay, in this journal, TALIP. Okay, this journal is special for low resource language processing problem. And we test some baseline method over the two data set. Okay, we can say fine-tuning a large language model gets the best performance. Okay, this is the last row is the fine-tuning result. Okay. Okay, so for fake news part, we can have a conclusion. So first, we demonstrate the potential of large language model for fake news detection. We can use zero-shot chain of thought prompting, agent, even LoRa to fine-tuning it. Okay, so we have a publication for this part. Second, we propose a hybrid framework combine large and small language model for multi-model fake news detection. And we also build a novel data, fake news data set for Swahili. And we give some baseline results for the data set proposed by ourselves. Okay, now let's move to another case called named entity recognition. So let's give first, let me introduce what is the named entity recognition. It's actually a subtask of information extraction. The goal of information extraction is to automatically extract the structured information from the unstructured documents. The internet is a big knowledge, or it's a big database, but it's very hard for us to directly use information or the data in the internet. For example, if you want to finding a job, okay, you want to list all the like software job position over the companies in like Fortune 500, Fortune 500 companies. Okay, this information are in the internet, but no database contain all the information we need, right? So we need to gather the information, okay, with some tools, okay, and IE is a technology to solve this problem or to meet this requirement. Okay, we also often heard a word called knowledge graph, right? Knowledge graph. So, what a knowledge graph contains? A knowledge graph actually contains many facts and not knowledge. A fact is expressed by a tripod. Usually it contains two entities and one relation. Like Harbin, capital of Heilongjiang. Okay, this is a fact, a triple. Okay, a knowledge base actually contains many triple. Okay, like this. So how to get these triples? IE technology, information extraction technology is to get the triples for a knowledge graph. Okay, so we know a triple contains two entities and one relation. So entity is what we will discuss called name entity recognition. Okay, it's actually a very important subtask. Okay, it's to find and classify names in text. Okay, find and classify names in text. Okay, for example, in this text, we can find many names. Okay, like Andrew Welke, Labor, and even Greens is also a name. Okay. So, and then classify the names, okay? Like Andrew is a person name and Green is an organization name, okay? That's a definition for named entity recognition. Okay, is it a challenge task? Okay, for names we can, names could be enumerated, like location names, okay? Our location names can be enumerated. It's also very hard, okay? Previously, people do use dictionary-based solution to solve NER problem. When we meet a word, it may be a name, okay? We just look up some dictionaries. Okay, if we find the name, the words in a location dictionary, okay, it's a name, it's a location name. Okay, but this method has many shortcomings. Okay, first, a name may be a person name or a location name. Okay, it has some ambiguity. Okay. Besides dictionary-based solution, we also use some, progressive people also use some rule-based solution, like Chairman Xi Jinping. Okay, so we know Chairman is a leading word. It will followed by a person name. Okay, so this is rule-based method, but you know, rule cannot cover all situation, so its recall is low. Besides, the name could have different categories. Okay, in news domain we have person name, location name, and organization name. But in biomedical domain we have disease names, drug names, and even DNA names. Okay, and in material domain we have different material names. Okay, electronic product domain, we have some different brand names, different like mobile phone series names. Okay, so there are many names. Okay, also lack of specifications. Okay, if people write names follow some specification, it will be easy to recognize them. But usually things not happens. Okay, even for biomedical domain. Okay, the doctor and the researcher, when they mention the same medicine, they may use different names. Okay, they mention the same disease may also use different names. Okay. Even there are some specification in biomedical domain, but people just do not follow them. Okay. Yeah, a polysem, one word could refer to different names, different kinds of names. Okay. There are also some nested names. A big name contains small names, and even some discontinuous names. Okay. Especially when you describe some the expression of disease. Okay, it will have discontinuous names. Besides, language is evolving. Okay, many names. This word yesterday is not a name, but today it's becoming a name. Okay, so. There are many challenges for this task. Okay, even its problem has been researched over, I think, maybe 50 years. Okay, that's the research, publishing statistic using a Scholar search website called Semantic Scholar. Okay. This website is also use information extraction technology to build. Okay. Okay. So there are many uses for NER, like we can use name entity as index. Okay. When you search your name in Google, okay, it will return many unrelated information. Okay, because Google is index over words, not entities. Okay, sentiment can be attributed to companies or products. Okay. Okay, we just. So how to evaluate the performance of name entity recognition? Here is an example. This is the input. Foreign Ministry spokesman Shen Guofang told Reuters. Here, Foreign Ministry is the organization name. Okay, it contains 2 words. Okay, so when we evaluate the results of NER, we need to consider based on per entity, not per token. Okay. So still we can use precision recall and F-measure to evaluate. So this is a confusion matrix for the definition of TP, true positive, false positive, true negative, and false negative. Okay. There are many natural language processing tasks. Precision recall and F-measure can be used almost all kinds of tasks. Okay, so remember there is a research diagram shift. Okay, so for NER, we have mentioned the dictionary-based, rule-based method. Now let's see the shallow machine learning method for it. It's kind of called classifier model. The most successful classifier model for NER is maximum entropy classifier, or maximum entropy model. Maximum entropy model is equal to logistic regression mathematically, okay? But why it's called maximum entropy? Why we need another name? Because with usually when we use maximum entropy classifier, we will deal with millions of features, okay? When you use logistic regression, okay, you only use maybe at most hundreds of features, okay? Why in natural language processing we have millions of features? Because let's answer it later, okay? So that's the definition for maximum entropy. Okay, it's here D is a context and C is a label. Okay, the label is entity label. It could be a person name or location name or organization name. Okay, so D is a context. Okay, FICD is a feature. Okay, lambda is weight for the feature. So we want to know whether a word is a person name, location name, or organization name. Okay, we do not know which is correct. We can make some hypothesis. Okay, we can suppose it to be a person name, and we can get a score. And we can suppose it to be a location name. We can also get a score. Okay, with this equation. So finally, we can choose the label with highest probability as a final decision. Okay, so this is this equation is a normalization item. Okay, so it can convert this value into a probability. This is what the feature looks like, okay? This is our training data or label data, like in Acrodia. This Acrodia is a location name. Quebec is also location name. Zantec is a drug name, and Su is a person name, okay? How to define features? A feature including two parts. One is its label, and the other is its context. Like the first feature is current label is a location, and previous words is in, and the target words is capitalized. Okay, this is for in Acrodia for this training examples. Okay, so we can observe the training data and to propose the feature. We think it will be useful for the name entity recognition. Okay, let's say the feature including two parts. Okay, the label and the context. Okay, we can just consider the label and the target word. Okay, so usually in a real natural language processing system, we will have a dictionary, okay, or lexicon. The size of a lexicon is usually 10,000 also, okay, 10,000 also. So a label can be a person name, location name, or organization name. Suppose we have three name labels, okay? So the combination is 3 multiply 10,000, right? Okay, so we can also consider many more words, like the word before the target word, okay? This is a combination, so we will have millions of features. okay, because it's a combination of two words, so the combination will be millions of. That's why we can easily have millions of features in natural language processing. Okay, so for maximum entropy model, we need to define features. We have to see how to define features. And the parameter for this model is a lambda, which is actually to control the important for each features. Okay, we can use training data to get the parameters. Okay, and when we get the parameters, okay, we can use this equation to make a decision. Yeah, when we use machine learning method, we need to know what's the parameters of the model, how to get it. Okay, what's the meaning of this model? So the shallow machine learning method has good explainability or interpretability. Okay, that's how to make a decision. Suppose you have the lambda, the value for each lambda. Okay. I just skip. It's not complex. Okay. And when we use classifier model, each time we only consider the label for the target word. Okay. Actually, the label has some relation. Like in this example, Mengqiu Huang is a person name. Okay, it has two words. So if we consider this is the beginning of a word, a person name, and this word should be a following word of a person name. So we should use connection between the labels. How to use it? We can use sequential labeling model. Okay, this is a sequential labeling model called MEMM. It's a variant for maximum entropy model. Its training process is almost the same. The difference is at inference stages. Okay, because previously we make a decision at each position, but now we need to when we make a decision, we need to consider the tags or the labels from previous token or words. So we need to we actually want to find a optimal sequence. Okay, not a point. Okay, we can use different inference algorithm like gradient inference or beam inference, weighted beam inference. Okay, so the most successful sequential labeling model for NER is conditional random fields. We can see the equation are almost the same. The difference is here C is a label sequence, plus it's a label. D is an input sentence. Okay, plus D is a context or target word. So now we need to find the best sequence path. Okay, not just not a point. Okay, but with graded search. Okay, although its search space is very huge, but we can use some gradient algorithm to solve it. With a successful deep learning method, so many deep learning models are used in NER problem, like LSTM sequence, RTS model. So this is input, okay, EU project's German call. And when we use deep learning model, first we can convert the word into word embedding, right? And we input a word embedding into a deep learning model. Here is LSTM. And then we can get encoding results, and based on the encoding results, we can get the output label. Okay, so besides one direction LSTM, we can use bi-direction LSM, and we can also combine LSTM and CIF together. Okay, because here, still, when we make a decision for this token, we do not consider, when we make a decision for this token, we do not consider the labels effect or we do not consider the effect of previous label. So we can add the CIF layer here to consider the effect from previous label. Okay, this is bidirection. Okay. This is the algorithm or the training procedure for bi-LSTM CIF model. We can see this method is proposed in 2015, okay, almost 10 years ago. So now NER is solved using large language model. Okay, here is a diagram for generative information based on large language model. With large language model, we can not only solve NER task, but also other information extraction tasks, including relation extraction and event extraction. Okay. So that's we still. To use a large language model, we can use prompt. We can write different prompt for different tasks. And we can assign the output format, okay, to get the format we want to use. Still, with the large language model, we can get some results, but it may not be good enough, so we need to improve it. So here we propose a method called character boundary aware and type decoupled name entity recognition enhanced by a post correction model. So the motivation is LLM is a generative model. So it usually it will generate a text span to indicate this is names. It may not pay enough attention for the boundary information. So we want to improve it from this point. Also, we know large language model is good at modifying something. Okay, so we can use it to when we have primary results, we can let LLM to modify it or to improve it. This is a framework for the solution. Okay, so we use some annotated data which contain boundary information to fine-tuning a large language model. Okay, we get the entity information, and then we propose a post-correction model. The post-correction is also a large language model which is fine-tuning by some data set, okay, which is good at modify which is good at correct the wrong names to correct ones. So how to indicate the bound information? We use different number to denote different bound information. Here, 1 denotes the beginning of an entity, 2 is inside of an entity. Okay. So the whole process is for NER. Okay, the process contains 2 stages. First is boundary detection. Second is entity type classification. That's why we call it type decouple. Okay, we actually, when we consider bound information, we do not consider its type. Okay, that's a instruction example for fine tuning. Okay, when you want to fine tuning a large language model, you have to give the correct format for your fine tuning data. So for post-correction model, we also need to prepare some fine-tuning data. Okay. Here we just give the output of the model. Okay. And then this is a correct output. So we hope the model can learn how to change the raw output into the correct one. Okay, this is some experimental results. We do experiment on MR30 dataset. It's a dataset for Chinese. Okay, and we compare with some state-of-the-art system, and we get comparable performance. Okay. This is an application ablation study. Okay, we can see the different modular, including bound-aware modular and post-correction modular, are useful for the whole results. This is a case study for how the post-correction modular works. Okay, so the contribution for the CBATD PC model is we propose a novel name entity recognition framework based on instruction tuning, and also we introduce a post-correction modular that iteratively optimize and refine the output of the base model. Okay, thank you.
Thank you, Professor, for the lecture. I have a question about the first part, about fake news detection, and my question rather practical. So, do fake news detection depend on previous news, and can the history of news be used to improve your algorithm by introducing the context?
So your question is, do the history of it's a good idea, but I haven't seen such works use Pure's. One. I think it's a good point. We can, it's this idea has been used in many tasks. It's like we can, compare we can consider Pure's fake news as some, we can start them, right? When we have a new, have a new coming text, we can compare the text one with the one we store in a database. Okay.
Okay, thank you.
Yeah, thank you. Yeah, that's a very good question. So the question is, a news may contain some fake information, some right information. Most of the situation, the right information is larger. Like you have 10 sentences, 9 is true, only 1 is fake. Yeah. Currently, we didn't distinguish the fake news with different degree of fake. Okay? If one sentence is fake, I would consider the whole news is fake. Okay? But you have mentioned a good research point. Yeah. So currently we need to give the explanation why the news is fake. So if we can point out which part is fake, it will be very useful. Yeah, so some research focus on this point, okay, to give you explanation for your decision and to point out which part is fake. Okay, that's a hard question. Okay.
Does your model use something open source resources, such as using contract systems, or your model search the internet for the information to judge if the fact is fake?
Yeah. I think for the real, for the practical system, this is necessary. But in our research, we didn't use the internet information in the model because we believe the large language model has contains some information from the internet. Okay, although it's not up-to-date information, but our data set is also not up-to-date. So I think the research doesn't limit the use of external resource or knowledge. We can use it. Yeah.
Okay, thank you, Professor, for your lecture.
Thank you, Professor. So I just wanted to be sure. So do I understand correctly that for fake news detection in Swahili, because fake news detection is more about classification, right? I mean, so fake news detection is more about classification. It's like classification. And so in this respect, even maybe, for example, MBERT or XLM Roberta, these are big models. They are better for African language translation. But for classification, small model turned out to be better. For fake news detection, for classification, small model, which is in CubeLM, it turned out to be better. So maybe not, maybe for translation in CubeLM is not good, but for classification it is better, right? No, I just want to say that in CubeLM is a small model, and it in CubeLM. It is a small model, so for classification, so for translation, it's not good, right?
Yes.
But it turned out, and so for translation, the previous models are better, like MBERT, which are big. But for fake news detection, for classification, it's okay. The small model is okay, right?
I think we cannot get this conclusion because the experiment is conducted on Swahili.
Yes.
And the small model is only 0.4 billion. But compared to large language model, its parameter size is small, but it's trained using Swahili data set. So its performance on Swahili is good.
So you mean that those big models? So you mean that the big models like MBERT, these models were not trained specifically on Swahili, right?
Other models, the comparator models, is not big models. Just the BERT and BERT is only, I think, 0.1 billion also. We do not compare with the large language model in this part.
So you mean AppleBert is also small?
Yeah, it's small. Only, I think, 0.1 or 2 billion.
Okay. So you just compare. So it means that you compared some small models, but this result is about fine-tuning some new small model for fake news detection, specifically in Swahili. Yes. Okay, understand.
Thank you.
Okay, thank you, sir. My question is about your experimental results in the post-correction model. Yeah, my question is about the experimental results in your post-correction model. I think there is a significant degradation in the result when the model is trained on in the error-only training and full training. So why is that this very significant gap in the F1 score?
Yeah, it's a good question. Yes, you mean this part. This line is this actually caused by the data in the training data. Okay. Here we use error-only training data, which means we want that model can recognize the output of the previous model and correct it. So we just use for this line we just use the error data. Okay. Output by the previous model. Okay, so, but we know many output are actually correct. So if we only use the error, we use error-only training data, this is not consistent with the real situation. Okay, it will cause the post-correction model to wrongly modify some correct results. So we change it, we correct it by adding some correct data, okay, not error-only training data. Do I answer your question?
Okay, so so the corrector must learn the robust representation of the correct entities, right?
Yeah.
The correction model.
Yes.
Okay, thank you.
Thank you.
So do you understand correctly that when you were doing fake detection with a multi-agent system, so the only thing you do, you provided specific prompts for agents, and the agents are actually the same language model.
The agent, one agent uses one language model. Okay. Different agent can use different language model. We actually do both situations.
And which is better, diverse language models?
We actually do not compare these two results, but according to my experience, diversity may be good. But depends on your model. If the model scale are same, diversity may be good. Okay, but if the model, the parameter of the model are different, okay, large model may be better.
But also, did you try to enhance the results by adding, for example, each model can have also a score which assess hallucinations or uncertainty of model answers. Did you try to take this score into account?
Currently not.
Okay.
Yeah, this is a good question, but it's hard to find a way to control the hallucination.
But you can use some score and you can make kind of...
Yeah. We can check the output score for each token. Yeah.
Any other question, guys?
Any question from online?
Are there any questions from online?
No. Thank you very much.
Thank you.